Okay, welcome to another game theory lesson. So we're looking at probability. These are some relatively basic probability concepts, although as I say that, if you haven't studied much probability, some of these concepts may be new for you. If you have, a lot of this should seem like review. This should seem really easy. Shouldn't take you much time. If you haven't, you might need to put in a little bit of work, but trust me, any studying of probability is not going to hurt you in the long run. In fact, I kind of think that this is something that, a whole class in probability is not a terrible idea for anybody in a university. It's just good understanding of probabilities helps you in so many ways. So, what is probability? Well, it's a numerical measure of the likelihood of one of the outcomes of an event, right? Like what's going to happen. Let's put some number, attach a number to it, and we're going to call that the probability. Well, this could be not expressed as a number between 0 and 1. So the chance of me showing up for the next lesson is 0.96. I don't know, probably higher than that. Or as a percentage. Or as a percentage, right? We're 96%. Books could use different methods. Sometimes I'll even go between them. It really doesn't matter. When you're doing a problem, just be consistent. If you wanted to use percentages, that's fine. If you want to use a number between 0 and 1, that's fine. Either way works. Just be consistent. So the probability of rolling a 1 or a 2, if you roll a die one time, right? There's 6 numbers on there. The probability you would roll a 1 or a 2, well, it's 2 out of the 6. So 1/3, 0.33, or 33%. Any of those ways are fine. I don't care, as long as when you do your homework or the test, just try to use the same method throughout the problem. Okay, I say in class, this is something I want you to work on your own a little bit and come to class prepared. I think a couple of these you'll find easy. For some of you, number 3 is going to be really tough. Some of you, number 2 will actually be difficult, but that's not a good thing. Number 2 shouldn't be too tough. The third one for some of you is going to be a bit tricky, but I at least want you to spend a few minutes thinking through what it would be. So, 3 different probability questions. Goes from easier to more difficult. So number 1, what's the probability of drawing 1 spade when pulling 1 card from a deck of 52 cards? I assume most of you have used decks of playing cards before, but there are 4 suits, spades, hearts, clubs, and diamonds. So there are 13 spades in the deck. So what's the probability of drawing 1 spade if you're pulling 1 card from a deck of 52 cards? Number 2, what is the probability of drawing 2 spades when pulling 2 cards from a deck of 52 cards, right? So first card has to be a spade, then you draw again. A second card is a spade, and note what I say up here, assume no replacement. So it's not like if you draw a spade, you're putting that back in, shuffling, and then redoing it. It's you pull one out, then it's not being replaced. 3 of these slightly more difficult. What's the probability of drawing at least 1 spade when pulling 2 cards from a deck of 52 cards? So you're drawing 2 cards from the deck. What's the probability you pull at least one of those as a spade? Okay, so I want you to work on that on your own and bring that to class. We're going to move on in the video. So expected value. What is meant by expected value? And often we'll just say EV. So again, we barely cover this, but it's an incredibly powerful concept, the idea of EV, or expected value. So an uncertain event can have several different outcomes, right? If you go to a night out, right? You could have a great time, average time, poor time, whatever. There's various outcomes that could happen. Even if you just go out for an evening. Here we're dealing with numerical values. So I mean, imagine you go into work one day and you are a salesperson and you're paid on commission, right? Well, the amount of money you make that day is going to depend on how many sales you make. It's an uncertain event before you show up, right? You don't know how many sales you'll make in a particular day. But there's some monetary value associated with each different outcome. And there's some probability of each outcome. Right? So the expected value of an event is the weighted average of the value of each outcome with the probabilities as weights. So to obtain the expected value, multiply the value of an outcome by the probability it will occur. So let's say a third of the time you make 4 sales, a third of the time you make 5 sales, a third of the time you make 6 sales. Now that's probably not too interesting because actually it's going to be the averages in the middle, but you know, a third of the time you do 4, a third of the time you do 5, a third of the time you do 6. Let's suppose when you make 4 sales, you get $100. 5 sales, you get $200. 6 sales, you get $400. Right? You multiply a third by 100, a third by 200, a third by 400. That's your expected value for the day. Some days you're going to make less, some days you'll make more, but the expected value, the weighted probability, use the probabilities as weights, weighted average of the value of each outcome. Mathematically, right, the probability event J occurs multiplied by the value associated with event J. That's how we would write this out mathematically. So the probability of the Jth outcome occurring and the value from that particular outcome. So if there are multiple possible outcomes, all you do is sum the expected value from each outcome. Right, going to work has some particular outcome, going to some particular sales job, but perhaps there's some other event, some other outcome, some other event that could happen. You could look at that as well. Okay, we'll go through a simple expected value example in through this video. It's the expected value of a roll of a die. When someone says they will give you $12 if you roll a 1, $18 if you roll a 2, but nothing if you roll a 3, a 4, a 5, or a 6. So, what is the expected value of the roll of a die? If somebody says they'll give you $12 if you roll a 1, $18 if you roll a 2, but nothing if you roll a 3, 4, 5, or 6. Well, think about this, right? Each roll of the die is 1 in 6 chance. So 1 in 6 times 12 plus 1 in 6 times 18 plus 1 in 6 that you get a 3 and you get 0 plus 1 in 6 that you get a 4 and you get 0 plus 1 in 6 that you get 5, you roll a 5 and you'd get 0, and there's a 1 in 6 chance you'd roll a 6 and you'd get nothing, right? So 3, 4, 5, 6 you get nothing. If you want to simplify, you'd say there's a 2/3 chance you get 0, 1 in 6 chance you get $18, and a 1 in 6 chance you get $12. So you multiply the probability of each event by the value if that event occurs. 1 in 6 chance of the 1 gives you $12, plus the 1 in 6 chance of the 2, which gives you $18. 4/6 of the time, or 2/3 of the time, you get nothing. Your expected value is $5, right? This is something, if you run, those who run a casino, they have to do this all the time, right? Absolutely have to, know what the expected value is so they could know what profits they would expect to earn in any particular game that they spread. So this says in-class exercise, but similar to the drawing a spade example I asked earlier. I want you to work through this on your own and come to class having taken a shot at completing this. So suppose you have a gamble that 1/4 of the time it's going to pay you $25, 1/8 of the time will pay you $10, but it will cost you $15 half the time and $30 an 1/8 of the time. What is the expected value of this gamble? I want you to work on that. Bring that to class, and we'll go through it together then. Risk aversion. It's worth talking about. We're not going to be spending much time on risk-averse behavior in game theory, but it's absolutely worth discussing briefly here. So the expected value is showing us the fair value of an uncertain event, right? The fair value. So if you own a house that's $200,000 house, if there is a 1 in 20,000 chance that your house would be destroyed by a fire this year, well, the expected loss is 1 in 20,000 times the 200,000. Right? It's $10. You know, most of the time you lose nothing. Every now and then you lose all $200,000, your $200,000 house. On average, the expected loss is $10. So the question then, would a person be irrational to purchase fire insurance for $15 per year? Right? That's paying more than the expected value of the loss. So would a person be irrational? Absolutely not. Right? $15 goes unnoticed by many people. To protect against a life-changing loss, $15 is absolutely not irrational. So the person is not irrational by doing this, but they are risk-averse, as most people are risk-averse, at least slightly. So this person would be considered risk-averse, and to define somebody as risk-averse, they would be a person who would choose a safe payment over a risky payment that has a greater expected value. Right? If you would rather pay the $15, which means your expected value is always $199,985. That's your expected value at the end of the year. You might lose the house, but you get repaid back in full, so you're always equal. If you'd rather have that $199,985 payoff versus $199,990, which is higher, but part of the time you lose $200,000. You're said to be risk averse. The book has many good examples. You could also be risk neutral if you'd only buy insurance if it's a reasonable value. You're risk neutral, or some people are risk loving. Not very many, right? They'd rather take a big gamble than not. One question that often comes up that people will ask is, well, what about people who go to the casinos? Right? Because if you go to a casino, you pretty much know, on average, you're not getting the right price. You're going to be losing money on average. Well, for casinos and for the lottery, there's a value to playing those, right? I mean, you're playing a game on those. And essentially what you're doing is you're buying entertainment. On average, you're going to lose if you go to the casino or if you buy lottery tickets. The people who do that are buying entertainment. Now, there could be some people who are irrational and think that they're, on average, they're going to come out ahead. But, for those who, on average, are playing a slot machine or playing blackjack or playing the lottery, right, you're not necessarily said to be risk-loving if you enjoy a gamble as entertainment. So there's a lot of literature on that. I just wanted to briefly say that it's kind of a separate category that we're not really considering as much in this course. Expected utility, this comes into play instead of expected value when you have risk-averse agents. So if you're risk-averse, then your utility from an action could be different than just the pure monetary value if it's a risky outcome. What we're going to generally note in this class is we're going to assume risk neutrality. Let me go back a slide. We're going to assume risk neutrality throughout the course, unless we note otherwise. All of the concepts we cover, it would be just perfectly fine to use risk-averse agents, but it just makes our lives easier, right? This is plenty complicated using risk neutrality sometimes. We could put in risk-averse agents. It really doesn't change much. It might make it a bit more realistic from time to time, but our methods are all the same. So if ever you're thinking, wow, I really wish we would show the risk-averse agents like they really are, know that we're not really losing anything when we assume risk neutrality. Just to wrap up, the probabilities, they don't come up that often, right? But there's plenty of times in the course that you're going to need to know how to do some of the simple probability stuff we've talked about here. Expected values, probabilities of an event occurring, especially if two different events have to happen for somebody to win a game, right? How do you figure that out? So things that I will expect you can figure out. There will be a couple problems throughout the semester where you're asked about this. So many times throughout this, it will happen. Spend the time you need to make sure you understand this stuff, and as always, feel free to come talk to me and ask questions if there are problems.